Hi everyone, let's discuss how to implement the code for linear interpolation in example number 1. Okay, if you recall, the problem for example number 1 is to estimate the natural logarithm of 2 using linear interpolation. We've already discussed the solution in the other video and you already saw this graph. Here's the MATLAB code that I used in order to generate the graph and the interpolated data based on the example number 1 problem. So let's go through this step by step. Of course, we all know what this is. This clears all the variables, clears the console, and clears the figure. Here are the given values. X0 is equal to 1, x1 is equal to 4, and x2 is equal to 6. And the corresponding f of x at x0 is equal to 0, f of x at x1 is equal to this value, and f of x at x2 is equal to this value. So naturally, I want to plot the true value meaning I want to plot ln of 2 from x0 to x2, or from 1 to 6. But I decided to just plot it from 0.5 instead of 1 to 6.5 instead of just 6. So that's why I have this 0.5 here, minus 0.5 here as the first data point, and plus 0.5 here to x2 as the second data point. So this is my y-axis for the black curve. The variable y generates the natural logarithm of x, and that's what we have here, that is indicated by the black line. Okay, so this is what this function does. It plots this black line, or it plots ln of the natural logarithm of the function x from 0.5 up to 6.5. Next is I wanted to mark these given values at specific points in the graph. So this is what I did in order to mark x0 and f of x0. So that's 0, that's 1 and 0, right? That's 1 and 0 here. This is what I did to mark x of 1 and f of x of 1, which is here. Okay, and this is the command that I used in order to mark x of 2 and f of x of 2, which is here. I also need to mark the true value of ln of 2, which is somewhere here. If you want to know what the true value of ln of 2 is, all you need to do is go to the command console and type ln of 2, log of 2. That's 0.6931, so we have 0.6931 somewhere here, and that's x equals 2 somewhere here. The next step is to mark the interpolated value of ln of 2 using the equation for the linear interpolation. So what I did is to first create a function. This function is called f1, and here is what this function does. If you recall, in order to make a function in MATLAB, the first thing that you have to type in is the word or the command function, and then the next is the return variable. So this is the variable that you will return to this main program, and then you type in the name of the function, which is f1. Remember that this function name must be the same as the file name, otherwise it will not work. And then you type in inside the parentheses the input variables. The next thing that I type in are the parameters that I'm going to use in order to compute for the variable that I'm going to return to the main function. So these are x0 and f of x0, x1 and f of x1, and of course x. We know these four as the given variables, and x here is the function, or x here is the value to which I need to compute f of x. So there are 5 input variables in this function f of 1, and I'm going to use all these variables here. So this is, if I select x0 like this, okay, MATLAB automatically shows where those x0s are. If I select f of x0 here, then I see that f of x0 and f of x0 are here. x1 is here, f of x1 is here, and the variable x is here. Okay, so once I've computed for that, I can now solve for y, and then I return y to the original or to the main file. Okay, so now that I've done that, I'm now able to compute for f of x at x equals 2. Okay, so this command plots the value of f of x at x equals 2. I need 2 points, right? I need x equals 2 and y at f of x equals 2. This is x equals 2 and this is f of x at x equals 2. Okay, so the value, as you can see, is 0.462098. I did the same thing for using, instead of x0 and x1, I used x0 and x2. So this is the command line for that. And the value of y that I get, or f of x at x equals 2, was 3.358352. As you know, or as we've seen in the example, this is a large error. This is a smaller error compared to this one. Now, the thing about functions is that not only can you input single variables or scalars, but you can also use as inputs vectors. So what I did here is to define a matrix or a vector x of a ranging from x of 0 to x of 1, because this is the range of values that I want to solve in order to determine the data points between these two values. So I want to interpolate between x0 and x1. That is, I want to put in data points between x0 and x1 as shown here. So that is why I wrote this vector. So this corresponds to x0, which is 1. This corresponds to x 1.1. This corresponds to x equals 1.2. This corresponds to x equals 1.3, and so on and so forth. And what this function does is it's going to solve all the values of x of a, okay, as I defined here, okay, and then plot it. So the function not only accepts scalars, but it also accepts vectors such as this. So this is the advantage of using a function such as this. Here I did the same for a different range from x0 to x2. Okay, and this is the function that I used. Then these commands here are just to provide some aesthetics to the graph.